Well, I'm up here on a ladder. I tried to hang a security camera with twin floodlights on it from this plastic box, and it ended up breaking off the two attachments. I've super glued them back together, but they don't seem to be strong enough. I'm not going to trust those, so I need to come up with a different way to actually attach those camera with that'll have much more strength without having to tear up all this vinyl siding and to replace that box. So we'll see what I can come up with. So I hung a security camera that has floodlights attached to it to one of these plastic boxes, and these tabs, these attachment tabs, broke off. The whole entire thing is an injection molded plastic, so it doesn't have the strength of something metal. It's nice because it doesn't conduct electricity, so you don't have to worry so much about your wires, but I need to have a way to hold much more weight than what this is designed for originally. And if these things break off, replacing this box can be quite difficult. So I need to come up with a design that will utilize the existing box with these broke off and create something that will hold much more weight. So what I've come up with is, through some research, I found that there are these little attachments for drywall anchors. This particular one has two zip tie type systems on it with a metal anchor at the very end of it that's threaded. Probably you can see that. So now you've got a steel thread and a load-bearing piece of steel. So what the plan is to utilize these little attachments here, go through, and then have the anchor actually supported by all the top weight on the top of this thing. So we'll see how that works out. So I'm going to assume that you have no access to the back of this, and all that you can see is this opening from the front. So what you would need to do is pull one of these tabs out and slide this attachment down through there. And to be able to do that requires a little bit of force, which is kind of nice in a way because this will spring back and you'll have the tab go through, and then you want that to be able to rest on something solid on the top. So that gives you a tremendous amount of surface area and strength to hold that in place, much more than in these straps right here. These two zip tie tabs aren't going to support the weight. It's going to be this metal anchor here because there'll be a steel bolt that will come up through there. So now we have an anchor that's held in place by this tab down here, which has spring force on it because it has memory. It wants to go back. It's actually going to hold this in position pretty nicely, and it's going to keep the bar oriented on sitting on top of these surfaces, because as it pinches against these two zip ties, it's pushing it back and keeping the plate level, so the plate will always be in the correct position on the top. So that worked out pretty well. Now we need something for the metal plate. There's usually a metal plate that gets bolted onto these things. Usually it sits across here, but with those bolts gone, we're going to actually use metal connectors on this side. So for that to sit down on, to have a surface to sit on, I took a little piece of PEX tubing, and it's I think it's a little over 1 1/8 long. You might have to play with the length a little bit. And then I cut about a 3/16 inch gap down through the side of it, to just a channel for this thing to slide around these. Because once this is assembled, you want to be able to use this top piece as well to clamp down on the top. And then I also put a little notch on the other side. If you can see, there's a little tab here that actually sticks up above. So when we try and assemble this, we want to make sure that it's able to, let's see if I can get this on here. There it goes. And then the tab will actually align with the notch at the bottom. So now you have that surface sitting down, and it's actually, when you tighten the bolt down, it'll actually push this tighter against these straps. And so It will keep the orientation correct and kind of provide a surface for this metal plate to sit down on top of. That it doesn't need to have a lot of strength because all the force is going to be, this plate, this ceiling junction box is going to actually be hanging upside down. So all the force is going to be pulling down on a bolt that's going down through here. To make these little spacers, there's a couple of things that need to be done. The inside diameter of these happens to be a little too small for this plastic cap to fit down into. That's a ½ inch on the outside. These are under a ½ inch on the inside. So the first thing that I ended up doing was taking a drill and actually drilling out the inside of this. So it's not hard to do. ½ inch drill bit. And that's done. Now just cut them to length and then slice a slot down through there. I used a razor knife to cut through this. It's pretty soft plastic, so it seemed to work pretty well. So you can cut this part to length. I used a hacksaw on one and then I used the razor knife. Both ways work pretty good. Once you get it cut to length, the next step would be to put a little slat down the side. It needs to be around probably 3/16 of an inch wide. I just used my razor knife here. You can just cut it straight down. Keep your knuckles over the edge of the surface of the board. So I got this over at the edge of the table. And just go as straight as you can, straight down on it. It slides down through pretty good. And then to the other side of the slot. It doesn't have to be perfect, but you're going to want it about 3/16 of an inch, and you're going to want it pretty straight so that you can get it down through between those two zip ties that you're going to be going down through. So there you have the slot cut through. Hopefully you can see that. And then directly across from that slot, you're going to want to put a little notch at the bottom. I marked the top of this where I drilled through with ½ inch drill with 2 dots, so I know where the top is. So the bottom directly across from that slot. Keep your fingers out of the way in case the knife slips. Just put a little V-notch in there. Doesn't need to be much. Just something to allow it to sit down against that extra tab that's in there. And so now you have a little V-notch there across from the slot. And what that'll do is help orient it so that the slot is towards the back. Helps let it sit a little bit more flush against the side of the box. So these metal plates seem to be a little too big for these boxes because when you try and set them down in there, they hit on the top edge. And this has been consistent with the other ones that I've tried too. So this is slightly under 4 inches. This box is even smaller than that. The outside diameter is probably around 4 inches. So the plates in the box don't fit. So what you would have to do, and what I've done in the past, is if you squeeze the sides of these boxes, you can get this plate to sit down in there. However, that causes stress in the box and it's no longer a round shape. And that stress over time could cause this thing to break. It's not something that's desirable at all. So what I'm going to do is grind the brackets down. I know there isn't a lot of room here because they take the slots right to the end, but that is not a good condition to have all that stress on her. You can see right there that it's in at the top portion there, and it's overhanging the entire thickness of the plastic. So that's got to be reduced down in size. And I'm also going to trim off on this little clear plastic cap here, trim off these corners so that it'll sit down as flush against the side of this box as possible, and that'll allow us to have a cap and a sealed system on there that we can just run a 1/4 inch bolt through. Since wiring is going to be going inside of this box, it should be protected with the caps on the ends of the wires, but you still want to try and prevent anything from shorting out. So one thing that I wanted to check was to make sure that none of this conducts electricity, and you can see that there is no conduction there at all. So this entire 3-inch long bolt that's going to be going down through here will be protected by this plastic shield, and the wires that will sit down in here, if they're properly connected to each other with caps and tape, should prevent that from happening, any kind of a short. So I made a mock-up and assembled one side of this assembly. As you can see, there it is, the parts installed. And what I did was I picked the one on this side here, and then we'll pick the one on the opposite side over here. These are equal distance through the center, so that'll keep the bracket going through the center. And I trimmed off the inside edges of this so that this could sit more flush, and it's pretty robust. It's going to stay right there. And if you flip it over to the other side, this would be up in the ceiling, and you can see that it's a pretty good design. It clears the truss here with no problem. The metal would have to be, since this is all steel, it would have to go down through this plastic in order to fail. So I don't see that failing unless there's extreme force put on it. So now it's just a matter of assembling it. And to do that, let's just take the screw, which is right here. I also trimmed a little bit off of this bracket, off the ends of this bracket, so that it would fit better down in there. So then you just take and put the screw down through there, and it's going to follow along where those zip ties are. So it's actually guided all the way down to where the threaded section is, and it just easily screws in. Now you've got metal to metal threads. And that's not going anywhere. That's very strong. You've still got plenty of thread penetration on the back side, and now you've got steel to steel all the way through. So that should solve the problem, and it'll be very strong, much stronger than the original. And it's removable and replaceable. It's a robust enough design that you can take it apart, put another one on, completely take it apart, everything stays in position, and then you can reassemble the new stuff. It'll just go right down through there again, once again. So it's really something that I think is going to be much better than the original, and it will be very strong. So just one more thing. Now that this design has been redone, it's extremely strong, and the screws probably aren't going to fail. So the next weak link in this box will be, as you can see, it's just got plastic attaching it to the truss, and a little thin piece of plastic that's holding that thing together. So the next solution, because this whole box could now pull right off of the truss completely, because you've got just those two nails. If you're going to put a lot of weight, like a ceiling fan or something on here, the next solution above this would be to go with, they have these metal brackets, and this end can telescope out so that you can actually cover any span between trusses. And then the metal box is screwed through a metal bracket onto the back. This, of course, can be loosened up and adjusted and slid down. So you would probably want to put one of these metal brackets on next, and you could attach it through. This box actually has accommodations on the other side. You can see down in there, there's actually hex nut little cups for the nuts to fit in through there, and then you would just drill that hole out to let the screw come through. So you could actually attach that metal bracket to this plastic box. But at that point, I think I would just probably switch out the whole system and get one of these nice metal boxes and get the support going across. It's going to be far stronger. There it is, the final design, completely installed, and I think that's going to work pretty well. These are the things that I used on this project. I used a strap toggle that was a 3/16 inch size. Worked really well. I tried another brand of toggle. This has a different design to it. Can't really control this end very well. It doesn't flatten down well. That you don't have two straps, you just have a single serrated area going down. Did not work well, and I don't recommend using that. This particular toggle has these two straps that are parallel to the end, and you have two handles at the other end, so you can actually control what the toggle is doing. And you want to be able to insert it easily and then get it back parallel again. And when these two levers are even, that end is parallel with it. Works really well. Used 3-inch long screws. The toggle pack comes with 2.5. I wanted a little extra thread sticking through, so the 1024 thread actually fits into the 3/16 24 very well, so there's no problem with that. Cut these down. The final length on these ended up being 1 3/16 inch. That's to allow for the extra thickness of the head of the bolt, which ended up being a little bit taller than the original bolt, so I wanted to nest that down in to have it flush with the top of the box. Flathead screwdriver to pry open the little area on the bottom of the box to allow the toggle to go through. Razor knife, of course, used that to trim all the plastic with. PEX tubing, which I used a 1/2-inch size for that. Worked well. Allowed the cap to go down inside. And a cordless drill with a 1/2-inch bit to open up the PEX tubing a little bit. I also used a hacksaw to cut one of the pieces of plastic with. Then I did another one with the razor knife. Both ways work. Hacksaw leaves a little burr on there, so you have to clean that off after if you use a hacksaw.